that we are getting a bit deeper understanding of formation of Himalaya, and for the understanding of that Himalayas, will not utilize without understanding, better to say, without understanding the concepts of plate tectonic, continental drifts, sea floor spreading, and convectional current of magma. We'll try to understand the formation of these Himalayas in, I said that, in a shorter interval of time. So let us move ahead, and for that we can be able to see like some basic things for the formation of Himalayas. What are the things that we'll cover here? The Himalayas are of, I said that, Trans-Himalayas, Himalayas and Provincial Hills. And in the Trans-Himalayas, you know that it is formed before the Himalayas. And this Trans-Himalaya is made by the ocean. It is made by the ocean continental convergence. Here it is, under the Trans-Himalaya, there is a Karakoram range, there is a Ladakh range, Jaskar range, and Kailas range. And Kailas range is a continuation of Ladakh range in Tibet. And we'll also see the formation of, I said that thereafter, I said Himalayas, and Himalayas are made by, I said that, continental convergence. Here there are the types of Himalayas that we'll have to see. Here, Greater Himalayas, Middle Himalayas, and Shivalik range. Greater Himalaya is also known as Inner Himalayas or Himadri. Middle Himalayas are also known as Lesser Himalayas or Himachal Himalayas. And Shivalik range is also known as Outer Himalayas. Understood? Here, in the Provincial Hills in the northeast, there are, I said that, Arunachal Pradesh, some Nagaland, Mizoram, Manipur, Tripura. These are the states are there. In that one, the mountain has been formed during the formation of Himalayas. These are Patkai Boom, Naga Hills, Manipur Hills, Mizo and Lusai Hills, Tripura Hills. These are the different hills which has been formed in the northeast during the formation of Himalayas. So, today, I said that before getting into the understanding, let us understand which are those Himalayas are. I said there is in this one, there is I said there is a Karakoram. In this red color, you can see Karakoram, Ladakh, Jaskar, and continuation of Ladakh in Tibet is Kailas range. These are Trans Himalayas. And here we have a Greater Himalayas. You can see from that, I said that, from the west end of to this east end, that is Nanga Parvat to Namcha Barwa. And here we have Middle Himalayas, and here below that there is I said that in the southern part it is Shivalik range. Understood? So these are the actually Himalayas, and these red color are Trans Himalayas, and here the green color you can see it is your Provincial Hills. I said Patkai Boom you can see, or Patkai Hills, and then the Arunachal Pradesh and Naga Hills in the Nagaland, and Manipur Hills in the Manipur, and Mizo and Lusai Hills in the Mizoram, and Tripura in Tripura Hills in Tripura. So these are the understanding we'll have to see. Here GH means we have written here Greater Himalaya, MH means Middle Himalaya, and SHI means Shivalik range. So we have to understand the formation of this, and here I can say like basic understanding I'll give first. For the earth, earth is like an egg itself. You know that in the egg, what you can say, there is one outer layer in the egg, that is like a crust, that you can say like a crust. Similarly, earth, very thin outer layer is like a crust. And thereafter, the white part of the egg, this white part of the egg is known as, you know that, it is a kind of albumin, white part, and that is known as, in the earth we can say mantle. In the earth we can say mantle. Here, and then yellow part of the egg is yolk, you must be knowing, and here this is the interior part of the earth, it is core. So similar to the, I said that egg, similar to the egg, we can say there is a crust, there is I said mantle, and another one core. This is clear to everyone, and the detail of the Earth's interior in the different classes, Earth's interior classes, you can understand. But here we are just driving you that this geography part is very easy. Only we need to understand what are the basics are there. These basics, if you are understanding, so you can be able to understand the geomorphology, climatology, different section. But here Same way, I am trying my best to understand the formation of Himalaya with some basic concepts without using the hard concepts of continental drift, plate tectonic, convectional current of magma, and sea floor spreading. No need to know, but I am trying my best to understand. Okay, and it is very much important for civil services examination as well as other state public service commission examinations. So here, this is perhaps it is clear to all of you: crust, mantle, and core. Now we'll have to see, like, you know that below the crust, mantle exists. So now we can see that there is this is our continental crust, and this continental crust, if we can see that its thickness is around 35 to 45 kilometer, and below oceanic water there is an oceanic crust, and you can say that this is 6 to 7 kilometer thick. I think it is clear. So continental crust 35 to 45 kilometer thick, and the oceanic crust 6 to 7 kilometer thick. Now we have to understand this continental crust on which we are standing. The continental crust on which we are standing, it is made up of silica, like I said that you can say sand. It is like a sand. And now oceanic crust, which is I said that 6 to 7 kilometer thick, on which water is, oceanic water is, I said that overloaded, and here it is made up of more of iron. If it is more of iron, can you say that which one is more denser? Yes, oceanic crust is more denser, more heavier than the continental crust, because continental crust is mostly made up of what? Silica. If it is made up of silica, you can say that it is a lighter. Silica, you know that it's like a sand, and it is made up of, oceanic crust is made up of, I said, more of iron, therefore it is heavier. This is clear to you. And below crust there is a mantle starts, and then the first layer of the mantle is upper mantle, which is very solid, and it is also attached with the crust. So we can say that this crust and mantle are attached with each other, and these are known as, we can say that crust and mantle, upper solid mantle, is known as lithosphere or plate on which we are standing. It is not only crust, it is also attached with the upper part of the solid mantle, and together they are known as lithosphere or plate. Understood it? And now thereafter we'll have to see, this plate or lithosphere is floating over below in the mantle. Below there is a semi-molten asthenosphere, which is known as asthenosphere. So this plate is floating over semi-molten asthenosphere, like sheep is floating into the sea. Yes or not? So I can say that similarly this plate is floating over semi-molten asthenosphere. And now now we'll have to see what is continental plate. If somebody is asking what is continental plate or continental lithosphere, you can say that it is made up of continental crust and upper solid mantle. Somebody is asking what is oceanic plate, so you can say oceanic plate or oceanic lithosphere is what? Made up of oceanic crust plus upper solid mantle, and they are floating over, I said, semi-molten asthenosphere, like a ship is floating into the sea. Similarly, it is also floating. And here let us see what is happening. Now we'll have to see what is happening inside the mantle. Inside the mantle there is a molten rock. Inside the mantle there is a molten rock, and this molten rock is known as magma. It is known as what? Magma. Is it okay? This molten rock is known as magma. Here what happened inside the earth, in the mantle, under the influence of radioactive minerals, means they used to liberate the energy or heat, and by the release of energy the rock get melts, and the molten rock start moving upward. You can see here the molten rock start moving upward. When the molten rock is moving upward, because any molten things become lighter and expand and lighter, and the lighter things start moving upward and they start convecting upward, and here it goes and start accumulating below the Earth's plate. Here start accumulating slowly and slowly. In the large area it has accumulated, and then due to the accumulation start spreading. And when it start spreading below the Earth's plate, after moving away to a larger area, in the larger area, what happened? It becomes so heavy and colder relatively. And because it moves away from the source of energy. Here it is the source of energy, it moves here, then here it is. So by the time it becomes, suppose here temperature is, I said that 1300 degree, and here it moves near to the Earth's plate in the hundreds of years, then move away, start spreading below the Earth. So it is taking too much time. And in the too much time, so it starts slowly and slowly, its temperature decreases, and decreases means it started, what I said, that become heavy. And when it start become heavy and then getting down. This whole process is known as convectional current of magma. This whole process is known as, what I said, that convectional current of magma. So you can say that this convectional current of magma is, when it is moving like this, it is putting in a frictional drag on the Earth's plate. Putting in a frictional drag. If it is putting in a frictional drag, then the Earth's plate, that is continental plate or oceanic plate, start breaking and diverging into opposite direction. Start breaking and diverging into opposite direction. So that is known as, I said, that divergence. And similarly here also, convectional current of magma, making the plate under the frictional drag, making the plate diverge away in opposite direction. And plates break and diverge away in opposite direction. So here it is also plates are diverging, here the plates are also diverging. So such two divergence, here it is an, I said that divergence, here it is divergence, and such two divergence causes one convergence in between. This is clear. So the formation of the Himalaya, we need to know, I said that convergence. Understood it? So, and you might remember that they are floating over, I said that semi-molten astrosphere. Let us move forward and let us see that what about the two continental plates. If there is no two continental plates, then they are made up of silica, mostly of silica. So having same density, when the two continental plates are there, and they are moving, the two continental plates are there and they are converging. So these two continental plates putting same pressure over the astrosphere, like a sea, in the same pressure, and when they are converging, so they will collide with each other. They will, what happen? Collide with each other. Understood? This, during such continental convergence, there is a collision will take place. What will happen? Collision will take place. But when I say that when there is a, one is oceanic plate and another is, I said, continental plate. And I have said earlier, you can go back and watch the video, that oceanic plate is mostly made up of iron. Oceanic plate is mostly made up of iron. So it is, what I said, thicker and heavier. So when a continental plate and oceanic plate, suppose it is an oceanic plate, when oceanic plate and continental plates are converging, the denser oceanic plate, its density is higher. So what happened? The denser oceanic plate will start by putting more pressure, and it will start moving under the less denser continental plate. And you know that less denser continental plate. Why am I saying less denser continental plate? Because less denser continental plate, it is because of more of silica. Where there is a more silica, more sand, that density will be less. So again, denser oceanic plate and one it is continental plate. Less denser. When they will converge, what will happen during this convergence? The less denser oceanic plate, more denser oceanic plate will subduct below less denser continental plate. So during such convergence, what happened? When you can see that there is an, what I said, oceanic plate is subducting below less denser continental plate when they are converging. And here you can see the oceanic water. Here, let us understand another part of it. When it is converging and it is subducting below, then there is a formation of one, I said that accretionary wedge sediment. What is accretionary wedge sediment? Understand? Again, very basic beta. I said that when a plate is moving downward, oceanic plate is moving downward, then there is some scratch. Some scratch will be there and some accumulation of sediments will take place. So those sediments are known as, you can say, accretionary wave sediment. Understood? When oceanic plate is subducting below less denser continental plate, due to that you can be able to see there is some deposition of, I said, sediment, and these sediments are known as accretionary wave sediment. Understood it? This is clear. How the accretionary wave sediment come into play when there is an oceanic continental convergence is taking place. Understood it? Now, another point that we are going to see here, when accretionary wave sediment is taking place along this subduction zone, this is your accretionary wave sediment, and when it is taking place at the same time, reverse from the continent side is also depositing the sediments, and these sediments are known as river deposited sediments. And these two sediments, which is also known as these two sediments, means river deposited sediment plus we can say accretionary wave sediment, known as, I said, geosyncline. And this is the real cause of formation of fold mountain. This is the real cause of formation of fold mountain. And here we can see like what happened during this when the oceanic plate is converging. So what happened when this oceanic plate is converging? What is happening? So when it is converging, this accretionary wave sediment and river deposited sediment under the compressional force, these sediments buckled into the fold mountain, and there is a formation of fold mountain. Similarly, Andes mountain, similarly Rockies mountain, which has been formed, Andes mountain on the western part of South America and Rockies mountain on the western part of North America. So Andes on the South America western part and Rockies on the western part North America. Similarly, it has been formed. So this process, I think you have been able to understand that how do the fold mountains used to come. They are the important parts are the sediments. And which two sediments we have been able to see? These two sediments are like accretionary wave sediment and another one is river deposited sediment. These two sediments, under the compressional force, it has been buckled or folded into fold mountains. So perhaps this is clear. And at the same time, another important point that we'll have to understand, what happened during this trillion tons of, I said that plates are converging and one is going downward. So what happened? Lots of friction. When there is lots of friction will take place along this zone, then because of the friction, heat will generate, and this heat will make the rock to melt over there, and then molten rock is known as a magma. Then there is a formation of magma, and this magma, you know that in any molten things expand, become lighter and start moving upward. And when it start moving upward, then it can cause, I said that, explosive volcanic eruptions. Understood? So this way there is an explosive volcanic eruption has been taken place. I think it is very clear to all of you. And let us few things that you have to remember before getting into the, I said, real formation of Himalayas. And I have said earlier that we have to understand in the formation of Himalayas, one part there is a Trans-Himalayas where there is a Karakoram, Ladakh and Jaskar is there, and continuation of Ladakh range is Kailas range. Is it okay? And into the Himalayas, we have to see, like I said, that there is an, I said, Greater Himalaya, Middle Himalayas and Sivali. But these Himalayas have been formed in different periods, different epoch, different time, you can say. That one time is known as Cretaceous period, which is known as from 135 to around 65 million years, 135 to around 65 million years. And during that period, you can say that around Trans-Himalaya has been formed. And you know that Karakoram, Ladakh and Jaskar. Ladakh continuation in Tibet is known as Kailash Range. So it has been formed. And during the tertiary period, one period is there from 65 million to 1 million years, there is a formation of Himalayas has been taken place. And there are some periods are there: Paleocene, Eocene, Oligocene, Miocene and Pliocene. So we can say that Cretaceous period to Paleocene, there is an I said that Trans-Himalaya has been formed, and Eocene, Oligocene, Miocene to Pliocene, there is a formation of I said that Himalayas. And which are the Himalayas? From Eocene to Oligocene, Greater Himalayas you can see, and from the Oligocene to I said Miocene, Middle Himalayas, and from Miocene to Pliocene, it is formation of Shivalik range. And this Himalaya has been formed by, again, let me make it again repeating for you. It is continental convergence, and Trans-Himalayas are mostly made up of what? Ocean continental convergence. So Trans-Himalaya is not a Himalaya, must understand. Trans-Himalaya is never a Himalaya. But it has been formed before the formation of Himalaya, Greater Himalaya, Middle Himalaya, Shivalik range. It has been formed before it. Understood? So suppose I said that, let us move little bit back and we will try to see. We'll try to see that here, this is this bigger blue color ranges are Greater Himalaya, and then here it is Greater Himalaya, here it is Middle Himalayas, and these are Shivalik range. And after that, suppose we are in India, here it is suppose Delhi, and here it is UP, Punjab, Haryana, all these are there. When we are moving towards this Himalayan region, the first we'll confront and we'll meet with what is Shivalik range, then Middle Himalayas, then Greater Himalayas. After crossing it, we'll see this Karakoram, Ladakh and Jaskar. This is your Karakoram and Ladakh, and this is Jaskar. Karakoram, you know, that is the second highest mountain peak of the world, K2 mountain peak. It is Godwin Austen, which is lies over there. So I said that Karakoram, Ladakh and Jaskar, continuation of Ladakh in Tibet, it is Kailash range. So after crossing this Shivalik, Middle Himalayas and Greater Himalayas, we will be able to see these mountain ranges. So crossing means trans. Crossing means what? Trans. So after crossing Himalayas, we will get some mountain, and that is known as a Trans-Himalayas. Crossing Himalayas, I'll see something that these are Trans-Himalayas. These are not Himalayas. Understood? And during the formation of Himalayas, these Purvanchal hills has been also formed. So the major part of the Himalaya, you know that it is Greater Himalaya, Middle Himalayas and Shivalik. It is made by continental convergence, and these are Karakoram, Ladakh, Jaskar, Trans-Himalaya, which is formed before the formation of Himalaya, and they are 110 to 40 million years, and they are, I said, oceanic continental, more of oceanic continental convergence. This is clear. Another point that we'll have to see, here we have seen that how do the oceanic plate is subducting below, and then there is an accretionary waste sediment and river deposit sediment has been buckled into the fold mountain. And then we have seen like here and here that due to the friction, the heat generated rock melt, and the molten rock is helping in the formation of magma, and this formed magma is become what is said that expanded, become lighter, and start what? Any expanded things are lighter, become lighter, and start moving upward. And then when it is crossing the earth and breaking the earth's plate and coming up, it is in the form of explosive volcanic eruptions. So here we can be able to see another part that we have seen in the different periods, that Cretaceous period to, and that in the in the regular classes I will make you to remember and all. But here I am trying to give you the basic concept, and then again I am trying to say that these are not the harder concepts. These are not the harder concept. Concept is very much important. Thereafter we can remember anything by practicing. So here it is from the Cretaceous period, that is 135 to 65, and there I have mentioned 110 to 40 million years ago our Trans-Himalaya is formed. Here it is Cretaceous period to first part of the tertiary period, Paleocene, we have been able to get the Karakoram, Ladakh and Jaskar, Ladakh continuation in Tibet, Kailash Range. And there is a greater Himalaya, middle Himalaya, Sivalik, which is formed from Eocene to Pliocene. Understood it? So here, let us see what is going to happen. First, we are going to see the formation of Karakoram, Ladakh and Jaskar. You know that our Indian Gondwana, there is a continental plate, and here it is Eurasian continental plate. It is Eurasian continental plate, it is Indian Gondwana, and between them there is a Tethys Sea. And below Tethys Sea, there is a one, below the Tethys Sea water, there is a Tethys oceanic plate. What happened? It is moving northward, and trying to converge with Eurasian continental plate. Here you can say, and this is the, I said that top view, and here I am showing you the side view. Indian Gondwana continental plate, this one is Indian Gondwana, and it is moving, I said that northward. It is moving, what I said that northward. And attached with this Indian Gondwana continental plate, there is a Tethys oceanic plate, and above it is Tethys, your Tethys Sea. When it is moving and then converging with the Eurasian continental plate. So denser Tethys oceanic plate is subducting. I have given the concept. Denser Tethys oceanic plate is subducting below less denser Eurasian continental plate. You know that? Why continental plate is less denser? It is because made up of more of silica, and silica means sand. And Tethys oceanic plate, why it is more denser? Because it is more made up of what? Iron. Therefore, it is subducting below. During the subduction, what can we say? There is a formation of accretionary waste sediment, and there is also river deposited sediment. You can see here, I have given this basic concept. I have given this basic concept here, you can see. I said that here, your Eurasian continental plate, it is, I said that it is moving. You can say that Eurasian continental plate and Indian Gondwana continental. Slowly and slowly it is moving northward. It is moving northward. And this is, I said that, known as hairpin like bend. This is syntaxian bend, and it is on the western part of India. So Indian Gondwana plate. So here this western syntaxian bend is going to collide first. And here you can see slowly and slowly Tethys oceanic plate is subducting below. I am showing this section. Understood it? So when it is going to collide, what happened? When it is going to, here it is convergence is taking place, and here the subduction is taking place. So what happened? What we have seen? The accretionary waste sediment and the river deposited sediments over there in this region, accretionary waste sediment by the scratch, accretionary waste sediment and the river deposited sediments. And you can see that now these two plates are far and slowly moving towards, and because of that you can see the distance. Now the plates are moving, and these plates are moving, and it has moved. Then deposited sediment over there has been buckled into the fold mountain of what? Karakoram, Ladakh and Jaskar, and it has been formed around 110 to, I said, 40 million. And you can say that Cretaceous period to Paleocene. These are the period where the Karakoram, Ladakh and Jaskar. You can see that, and during that period what happened also, there is an, I said that friction related heat generated, and I said due to that heat you can say volcanic eruption, magma formed and volcanic eruption also. In the Karakoram, Ladakh and Jaskar has, I said that volcanic eruption has been taken place also. Understood it? Now, this picture here I am going to show you to all of you again, and watch it very carefully. So we are going to see the formation of Trans-Himalayas and Karakoram, Ladakh and Jaskar. And here you can see that this is Indian Gondwana continental plate, and here it is Eurasian continental plate and Tethys oceanic plate. And this is floating over astronosphere. You can see floating over astronosphere. So here this Tethys oceanic plate is subducting below. You can see here due to the friction there is a formation of what? Magma. And this magma wants to come up and explosive volcanic eruption. So you can see that due to that, another picture you can see here, I said this Indian Gondwana continental plate, and here it is Eurasian continental plate, and this is Tethys oceanic plate. This is the, I said that Tethys oceanic plate, and this Tethys oceanic plate is subducting below, and during the subduction there is an accretionary wave sediment formation, and from here the river deposited sediments. And these two river deposited sediments, what happened when they are coming closer, then under the ocean continental convergence and then compressional force, the compression has been taken place, and this compressional force that led to the, I said that buckling of this mountain in the form of what I said that Karakoram, Ladakh and Jaskar. And already Kailash range is also, Kailash range is a part of Trans-Himalaya, and you can say that it is a continuation of Ladakh this way. Understood it? Another important, now these two plates, you can say that these two plates are little far away. Now they are, you can see that they are closer. Now what happened? Ocean part has been subducted. Ocean part has been subducted. Now there is a head-on continental collision, no subduction. So here it is a head-on continental. So after the formation of Karakoram, Ladakh and Jaskar, we will see the formation of Greater Himalaya, Middle Himalayas and Shivalik range. Greater Himalaya, Middle Himalayas and again Shivalik range. And I have said that beta in few minutes time, and then some maybe half an hour, maybe 40-45 minutes time, I'll make you to understand total period that I am taking to make you to understand this formation of Himalaya with the basic concept. Without understanding continental depth theory, plate tectonic theory, sea floor spreading, convectional current of magma, I have given some idea about convectional current of magma, how it is happening. Now here we have understood Karakoram, Ladakh and Jaskar formation of Trans-Himalayan. Now after the formation of the Himalaya, there is some portion of the, what I said, that Tethys Sea has been left, and this is in a deeper part. Therefore in front of this Trans-Himalaya there is what I said that deeper part is known as foredeep. F-O-R-E-D-E-E-P, foredeep is an, I said, deeper part in front of something, foredeep. So in the foredeep of Trans-Himalayas, the river has again, now the ocean has been finished. Ocean has been finished, oceanic plate has been finished. So there is no accretionary wave. Miss accretionary wave sediment come through the scratch. Yes or not? Now ocean has been finished. Ocean has been finished. Now only the river will deposit this sediment, that is also known as geosyncline. So only the river will deposit the sediments in the foredeep of which one? Trans-Himalaya. And now we can be able to see in the foredeep of Trans-Himalaya, the river has deposited their sediments. River has deposited their sediments. Again, in the foredeep of Trans-Himalayas, I said that deposition of sediments in the foredeep. By who? River. And now, under the continental, you know that once somebody is coming head-on collision, there will be more force, yes or not? So at that time, this deposited sediments by the river into this Tethys Sea in the foredeep area, what happened? Convergence and compressional force, continental convergence and compressional force caused, I said that formation of the first part, it is Greater Himalaya. You can see that Greater Himalaya, how it has been come into existence. Again, I said that I am making you, if you are studying for a longer period of years, you can understand today in this class in a very small interval of time. So here, you can say that here the Greater Himalaya has been formed. And at the same time, in front of the Greater Himalayas, you can see that a small, again a foredeep has been created. A small foredeep has been again created. And this foredeep, again by the river, I said that by the river has been deposited their sediments. Yes or not? Again, now it is this time foredeep of Greater Himalaya. And here now must be understanding, must be watching that now continental convergence is taking place. So here In the four deep of Greater Himalayas, yes, students, everyone, in the four deep of Greater Himalayas, what happened? Again, continental convergence compressional force has led to the formation of, I said, yes, Middle Himalayas. Middle Himalayas. Understood it? So this is the way that you can understand that how do the Middle Himalayas has been came into existence, Greater Himalaya, and thereafter I said that Middle Himalayas. And after the formation of the Middle Himalayas, again there is a small four dip has been created. And in this four dip of Middle Himalayas, means in front of the Middle Himalayas, deeper part, there is a river again deposited there sediments. So the river deposited sediments. And you must start understanding what is going to happen. This deposited sediments or geosyncline under continental convergence compressional force, and it has been buckled into Shivalik range. It buckled into which one? Yes, tell me. Shivalik. And then after the formation of Shivalik range, again there is in the front of Shivalik there is again a small four dip exists. And in this four dip, what happened? Again the river deposited their sediments, and now in this four dip river deposited sediment, and it became Indo-Gangetic plain. In the region of Punjab, Haryana, UP, Bihar, West Bengal, Assam, where there is I said that river has deposited sediments and it become Indo-Gangetic plain. I think you are able to understand very easily that how do the, I say that different Himalayas and then Trans-Himalayas or Himalaya has been come into existence. Understood it? I think you liked our video and this channel also. And if you, I said, if you like it, and if you have any doubt related to any concepts, you can ask me. But I said that I will go much deeper into the coming classes for the formation of Himalayas, and it can take several classes, because I'll say that why do the Eastern Himalaya is higher, Western Himalaya is relatively lower, how do the, I said that Bengal plain came into existence, why Eastern Himalaya is steeper, Western Himalaya is not steeper, and why there is a more landslide occurs in the Eastern Himalayas and Western Himalayas. It is naturally I am talking about less, but in the present time anthropogenic factor make the Western Himalaya, that is Uttarakhand, Himachal Pradesh, in all areas there is a more landslide. But natural factor, anthropogenic factor is two, both are different. Yes or not? Another point that we'll have to also see why there is a very large valleys in the Western Himalaya, but there is an, I said that Eastern Himalaya is devoid of valleys. Understood? So several concepts, and why do the Mount Everest come into existence, why it is very highest peak, and why in the between these three ranges, Greater Himalayas, Middle Himalayas, Shivalik range, and all, there is some faults are occurring, gaps are occurring, and then there is cracks or joints are there, that is causing movement during the plate movement and causes earthquake. That these are the deeper things again are there, and I will try to enrich always to understand that every concept which is needed. So I try my best to understand this formation of Himalayas without the, I said, continental drift, I said plate tectonic theory, and I said seafloor spreading, and another concept, it is convectional current of magma. So I think you must like this video. Please, again, any doubt, freely ask your question, and we'll see further more deeper concept. Till then, thank you.